Now we're ready for polynomial inequalities. And so a lot of this we've seen in different places, and we're putting it all together now. So graphing polynomials, we've already been through. So the first step we're going to do is graph all these polynomials. I'm going to be going through this, and you know how to do this, so you can just go ahead and do that. Make sure that we get the same graph. That's going to be important. And then we're going to interpret our graph to answer the inequality. Okay, so here we go. The first one is p of x. And so in order to graph a polynomial, I must identify the zeros, their multiplicities, their behavior, and also the end behavior. I have those listed on your sheet. You can fill that in as you go. But basically, there are three zeros, and so the zeros here, x is 3, x is -2, x is -5. Okay. This has a multiplicity of 1. You look at the power on there. This has a multiplicity of 1. This has a multiplicity of 1. This is going to cross because the multiplicity is odd. For the same reason, this will cross and this will cross at the x-axis. Now, that tells me about the zeros and their behavior. In addition to that, I need to know the end behavior, what's happening at the ends of the graph, way to the left and way to the right. If the leading coefficient is positive, and it is, it's up to the right. Now, then you compare it with the degree of the polynomial, which is 3. If I multiply these together, x to the third would be the highest, or you can just add up the multiplicities. It gives you the degree. If the degree is odd, and it is, so we have a positive odd is what we're looking at. The positive gives us up to the right. The fact that it's odd says that the left will not follow the right. It will switch it up. So that's enough to sketch our graph. Let's sketch him. Let's see. Here is my grid. Let's mark our places. We have -5, -5. We have -2. And then we have 3. All right, this is 3. So let's sketch him. He's going to look like this. He's going to cross. He's going to cross, cross, cross. And how does he start? He starts down left. So I'm starting down, and I'm going to cross, and I'm going to cross, and I'm going to cross. This is what this looks like. Now it's -5, -2, and 3. Okay, that is what my graph is. Okay, I'm going to come back and answer this question after I go through and graph all these. I'm going to go through and graph all these. This is the old news, so you guys will be good at this. Let's see. The x is -2, multiplicity of 3, cross. X is 3, multiplicity of 1, cross. X is -4, multiplicity of 2, bounce. Let's see, it's a negative. That means down to the right. The degree is 3, 4, 5, 6. It's even. So left will follow the right down left. Okay, let's graph this guy. Looks like this. My roots are at -4, -4, -2, and 3. Okay, what is the behavior? It starts down left, okay, and down right, okay. It comes up to -4 and it bounces. So it's going to come up, it's going to bounce down. And then when it gets to -2, it's going to cross, and then it's going to cross. I get something that looks like this. All right, there's that graph right here. X is -5, multiplicity of 2, bounce. X is -3/4, multiplicity of 1, cross. X is 4, multiplicity of 1, cross. What about the end behavior? Well, leading coefficient is positive, up to the right. The degree is 2 + 1 + 1, even. Left follows the right, up left. Okay, so let's graph him real quick. All right. -5, -3/4, and 4. All right, how does it start? It starts up, and it ends up. So when we get to -5, it's going to bounce. It's coming down. It's going to bounce back up. Shoot. When it gets to -3, it's going to cross. And when it gets to 4, it's going to cross. It looks something like that. All right. Again, this is a sketch. If you were to put this in your calculator, these maxes and mins might go off your scale. They might be huge. But the sketch is all we need for our interpretation for inequalities. Last one. X is 0. Multiplicity of 2, bounce. X is -4. Multiplicity of 3, cross. X is -2. Multiplicity of 1, cross. All right, in behavior, it's negative, which means it's going to be down to the right. And then 2 plus 1 is 3 plus 3 is 6. It's even, which means it's also going to be down to the left. Left follows the right. All right, let's sketch this guy just like this. -4, -4, -2, and 0. All right, here we go. What happens at -4? Okay, first it's down left, down right. Now, what happens at -4? It's going to cross. At -2, it's going to cross, and at 0, it's going to bounce. So we come up here, we cross, and we bounce back down. Something like that. Now, let me check my work before I go on. Make sure I'm happy with what I had put down before. Let's see. I am agreeing. Okay, number 2. What happens? Yeah. Okay. I am agreeing. Okay, good. Number 3. Oh, I'm not agreeing. Let me check something out here. What am I not agreeing with? Oh, I wrote this down wrong. Gee, that's supposed to be a 2. That's what's on your worksheet. Let me do this better. Multiplicity of 2 says this will bounce. So what's going to happen here? It's going to change my graph. This one I got to change. We said 2 plus 2 plus 1 is 5, which is, so it's negative down right, but it's odd. This will be up left. That changes that to up left. That changes that to a bounce, across, a bounce. Okay, there, I'm glad I checked it. Let's see, we're at -4, -4, -2, and 3. All right, so what's supposed to happen here? Up left, we get to -4, it bounces back up. We get to -2, it bounces back up. Okay, we're coming down, bounce, bounce, cross. This is what this guy would look like. Let me see if that looks better. No, something didn't look right. Hang on, what's I doing wrong here? Am I looking at the wrong graph? I am. I'm looking at the wrong graph. For heaven's sakes, what's happening here? -2, bounce. 3, cross. -4, bounce. -4, bounce. Oh, I graphed it wrong on my sheet. -2, bounce. 3, cross. Okay, this was just, I did it wrong on my sheet. I'm happy with this guy. All right, now let's see. How about 4? I said negative, down, and down. So at -4, it will, oh, this is supposed to be equals 4. Well, I'm just doing this a little too fast. Equals to 4, not -4. 0, 4, -2. Let's try again. Let's try again. -2. 0, 0. 4, 4. All right. Slow it down. It gets to -2. It crosses. It gets to 0. It bounces. It gets to 4. It crosses. Okay. So we're going to come up from the left. And we're going to cross. And we're going to bounce. And we're going to cross. And that looks better. Okay. Sorry about all that. Now, let's... It's really important to make sure you are happy with your graph before you interpret your graph. Because if you're interpreting a wrong graph, everything's going to be wrong. So, let's go through. The first thing I want us to do, we're going to do this for all the, well, let's start with greater than or equal to 0. Where is this picture greater than or equal to 0? So I'm going to do this one in a lot of detail just to make sure everybody understands. This is X and this is Y. A graph is positive or greater than 0 when it is above the x-axis. This is where the positive y values are. It is equal to 0 when it's touching the x-axis, and it is negative when it is below the x-axis. So basically, where is this graph greater than or equal to 0? Anywhere it's touching the x-axis or above the x-axis. So right here and here. How I will answer this one, where is it greater than or equal to 0, will be where it's touching. So I'm going to use interval notation. Bracket means starting at -5 and including -5 all the way to -2. And then don't talk about where it went negative, but the moment it touches the x-axis, because or equal to, union it with -3 to infinity. That's how you'll answer greater than or equal to 0. Let's go ahead and do less than or equal to 0 while we're looking at this graph. Okay. Less than or equal to 0, p of x goes like this. Anywhere it's below the x-axis or touching the x-axis because or equal to. So this looks like this. -infinity to -5. Include the -5. This is where it's positive, but here's where it starts to equal 0 and then go negative and equal 0. Union with -2 to -3. That's how less than or equal to 0. Okay, now what if they didn't have the or equal to on there? What would that look like? Well, that would look like this. What if it's just p of x is greater than 0, just positive, not equal to 0? Then we just want to talk about this part and this part, not where it's touching. So that goes like this. Parentheses, -5 to -2, parentheses, union with 3 to, this is a positive, yeah, that's a positive 3, sorry about that. 3 to infinity is what that will be. Why am I calling that -3? I don't know what's going on here. To infinity. And then lastly, if we have to say, where is p of x negative? Where is p of x less than 0? We just want to look at this part, not where it's touching. So where is that? From -infinity to -5, parentheses, union, -2 to 3. Okay, and that's how that one goes. So that's number 1. Let's go over here to number 2 and answer that same set of questions. Where is this graph equal to 0 or positive? Touching the x-axis or above it? Touching the x-axis here, above it here. So let's see. That goes like this. From x is -infinity. Okay, -infinity all the way to -5. And then, but also this is positive. From here to -3/4. So all of this, from -infinity all the way to 3/4, is part of this answer. Because that's all included in that set. Don't talk about the negative, but then as soon as it hits 0, 4 to infinity, like that. Okay, where is q of x less than or equal to 0? All right. Well, where's it touching 0? Still same places. Right here, right here, right here. And where's it negative? Right here. So we have to include this point all by himself. And when you just have a single thing or a list that you can list, you put it in the list notation, which is that fancy braces. So we're saying -5, include that point, and then union this with interval, -3/4 to 4, like that. Okay? What about just plain old greater than? Q of x is greater than 0. Looks like this. We just want to talk about not touching, just above. Just that part. So this goes like this. From -infinity to -5, don't include the -5, union -5 to -3/4. Okay, good. Union 4 to infinity, like that. All right, well, what about, finally, where it's just plain old negative? Well, okay. Q of x is less than 0. Just talk about this part down there and don't include anything else. So this is just going to be from negative 3/4 to 4. We don't include where it equals 0, just below. Very good. Let's see if I'm agreeing with myself. Yay. Okay, good. All right, let's do these last two. Where is m of x positive or equal to 0? So it's touching, it's touching, it's touching right there. I want to include that part. So what is this number? I can't remember. Negative 4. Okay. Negative 4, negative 2, and is that a 3? Yeah. I had to redo that graph so many times. 3. Okay. So where is it positive or touching? Okay. Positive, touching, positive, touching, positive, touching. Wow. All the way. Negative infinity all the way to 3. All of that gets included right there. Okay? I wanted to do that. I'm trying to do consistent in the colors, so let me change that to black. So where is it positive or touching? Positive, touching, positive, touching, positive, touching. All of that gets in this set from negative infinity to 3. All right, cool. Where is it? Where is it less than or equal to 0, negative or touching? All right. Where is this? Negative or touching? Well, it's touching, it's touching, it's touching, and negative. So we have to include these touching places. So this will be a set of negative 4, negative 2, and then from 3 to infinity is where it's touching, equals 0, equals 0, equals 0, and negative. Where is this guy positive? All right. Don't include the touching, just include here, here. All right, so that means negative infinity to negative 4, union, negative 4 to negative 2, union, negative 2 to 3. That's how we're going to answer that. And lastly, where is this guy just plain old negative? Just here. Don't include where it's touching. So that's going to be from 3 to infinity, like that. All right, R of x, where is he positive or touching? Ready? Touching. Here, here, here. Negative 2, 0, 4, and above. So let's see. It is touching, positive, touching, positive, touching. All of that gets in that set. So we're going to go like this. From negative 2 to 4 in brackets. All of this is in that set. Negative 2 to 4. All right? What about where he's negative or equal to 0? Okay. Touching gets included, equal to 0, and then negative. So right here, this part, touching and negative, so it's going to be from negative infinity to negative 2, bracket, union. We have to include 0 because that or equal to is part of this set. Union 4, bracket 4 to infinity, just like that, okay? What about greater than 0? R of x is greater than 0. We don't want to include or equal to, just here, 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 here. So R of x greater than 0 is negative 2 to 0, union 0 to 4. Perfect. All right, and then what about where it's just plain old negative, not touching, just this part and that part? So that's going to be negative infinity to negative 2, and then to the right of 4 to infinity, just like that. All right, let me see if I'm happy with what I put down. I think it looks okay. That's inequalities.